statistics. So today, just a snapshot of what we were covering. We went over the syllabus and the norms for the class, and then we're going to sign up for Sapling through Canvas. We're actually going to do that first and then get started on our activity that leads into the notes. So first thing is on Canvas, when you go into the course, on the left you'll see Macmillan Learning. You can click on this Sapling Learning and it's going to ask you to just input your name and email. You'll have to click yes a couple times, but then you're ready to go. It's going to take you to the dashboard where you will see the assignment. Most assignments are going to be on Sapling throughout this semester unless I tell you otherwise, or you see on Canvas that we did something on paper instead. Okay, so typically we're going to start with either a homework quiz or a skill check if we just want to practice some of the skills from the previous class, but we aren't quite ready for a homework quiz. We're going to do some group work that will lead through some of the vocab that you need to know. When we get to that point past the group activity, we will add notes together as a class, and I want you to add those in pen, so when you're looking back at your notes, you'll know what you had come up with as your group, and you keep that rather than erasing it, but then what I wanted you to know as a whole group, so you have that information moving forward with your homework. Then we're going to do some guided practice to make sure after the notes you understand kind of the expectations so you're ready for the homework. Okay, so starting out here, we're going to do this activity. And with this activity, this is the part that unless you're in class, you're not going to be able to do, because it asks you to survey 10 people about one of these things. Okay, so I'll let you read through kind of what you missed here, but then we're going to move on to the notes about it. So looking at the back side of your paper, okay, we have a bunch of just definitions here, and to go over those, we're going to talk about some of the things from section 1.0 in your book and some of the things from section 1.1. So these are the learning targets for section 1.0. You want to be able to, at the end of this, identify individuals and variables in a set of data, so we have to learn what those things are, and classify variables as categorical or quantitative. So here's the note sheet I was talking about. We're going to go over some of these things. You should be filling out these as we go. So starting out, statistics is the science of collecting, analyzing, and drawing conclusions from data. That's what this class is all about. When we say the word individual, it does not necessarily mean a person like it does in English. The individual is the thing that our data is describing. Okay, it could be people, it could be animal, it could be objects. Okay, but that is the who in your information. Okay, whether it's a person or not. Then the variable is the question that you're asking. That's the what are you talking about here. Okay, so that can take on different values for different individuals. You could have different answers to the questions. That's the whole idea, is we're trying to see the pattern in those questions that we're asking. And the questions we ask could be categorical in nature or quantitative. That's basically, is your question being answered with a subject that is a grouping, like a category, or is it being answered with a numerical value? Okay, and we're going to talk about these in terms of examples, but that then splits off into two more distinctions. We could have a discrete quantitative variable. That's something that is fixed. This, when we talk about it, is a count. Oftentimes when we talk about discrete, it's just a frequency value, and a lot of times this is going to show as a whole number. Okay? A continuous variable is a measurement instead. So when we talk about these things, a count is if the question asks how many and then fill in the blank, you would answer often with a whole number. But an exception to this is something like money. Okay, money is also a count. You count up your money, but it goes to 2 decimal places because the smallest distinguishable value is a cent for us. Okay, a continuous value measurement is at like your height or your weight. You can break it down into a smaller and smaller, more accurate measurement. So those are examples there. Okay. through that, you should be able to answer all of these questions. Okay, so if you didn't catch those, I'll let you pause the video and copy that down. But I want to talk about this last one here together. So when can numbers be describing actually a categorical variable instead of a numerical one? Okay, this is going to be when the numbers are used as a way to group rather than to define a value. So a couple examples of these that you're going to see is zip code. Okay, a zip code is a number that defines a region, but you can't have like an average zip code. Okay, so if you're ever worried about whether this is truly numerical or if it's categorical, think about taking the average value and if it makes sense in context. Okay, so if it doesn't make sense in context, it may be categorical. Another example of this could be a birth month number or months in general. Okay, you don't have an average birth month number. Okay, it's just the one you were born. They're using it as 1, 2, 3, 4, all the way through 12. Okay, so those are some examples of exceptions when a number is actually a categorical variable. Now, one thing I added here is this word. Sometimes you'll hear me refer to categorical as qualitative. It's another way to describe it. Your book uses categorical, so on Sapling you're only going to see this version, but you may hear me say qualitative instead. You are welcome to use either. Okay, moving on to this next little section here, we're going to do some more definitions. Okay, so a distribution, you're going to hear me say that word a lot. It's just a way to say how the pattern of your numbers look. So in your table that was filled out on the front, if we picked a variable like age, okay, the distribution would be the different numbers, the different ages that popped up for the people you surveyed. Okay, it tells us basically how the variable looks, okay, and then we can look at some patterns. Now, while we're talking about patterns, one way to describe the data or look at it displayed out is in a table. Okay, so that's here. We're looking at different variables here. We've got providence, gender, number of languages, etc. So our variables are generally going to pop up around the column headings, and then our rows are going to display our different individuals' responses. Remember, individual doesn't have to be a person, but it's who the information is about. So based on these variables, it looks like this situation, they were surveying so many people, and this was their response to different questions. For a categorical variable, usually we're going to use a bar graph or we're going to use a pie chart, depending on the options. So here, there were only 4 outcomes in this table, so a bar chart or a pie chart really would be okay. In general, a bar chart is going to be used for categorical more easily than a pie chart, just because pie charts you have to calculate some percentages, okay? When we talk about quantitative variables like number of languages spoken, and in this case it's a discrete variable as well since they're all whole numbers here. It's a count, not a measurement. A lot of times the dot plot is the easiest way to display that. You can also use a fancy type of bar graph called a histogram, but we're going to get into that in section 1-2 when we talk about displaying quantitative variables. Okay, now this is not on your paper, but we're just going to go over those vocab terms with some examples here. So it says, here is a table, and on a second day of a stats course, the instructor gave 40 students in the class's survey, and this just shows the first 10. Okay, so this row of 10 people that were surveyed are the individuals. In general, you're going to look at the rows for that. Then the variables are going to be the columns. And what we're going to do is go through here and we're going to classify these as categorical or quantitative together. Okay, so sex we're responding looks like as female or male, and so that is a category. I will tell you sometimes sex is classified into like numbers, 0, 1. And so with that, even though they would look like numbers, it is a categorical variable. Okay, class, that's another categorical variable. GPA here looks like numerical. You can have an average GPA. Okay, so numerical we're going to call quantitative for this class. Pulse rate is another numerical value, and it's quantitative. Dominant hand, that's going to be categorical. This would be an example of one that would be easily displayed in a pie chart because there aren't very many options. Okay, children in family, that's numerical, so it's quantitative. Homework last night in minutes. This is another example that we haven't talked about yet, so it may be helpful to add this to your notes. When we change homework or something that's numerical into intervals, then it changes to categorical. Okay, so make yourself a note on the exception list. Okay, intervals of values switches to categorical. Okay. All right, then we've got sleep in hours. Okay, that one is numerical, quantitative. And then do you have a smartphone, yes or no? That is back to categorical. Okay, so hopefully by that you should be able to do individuals and variables, and we can classify them further as quantitative or categorical. And from that quantitative, we've got two options, remember, discrete or continuous. Sorry, my thing's taking a while to load here today. We are going to have an example at the end here where you'll be able to practice these skills. Okay, a few more things we're going to cover. The chapters or the sections in your book are actually really, really long. So you'll see us spend 1 to 2 days on each section. 1.0 was an introduction, but 1.1 is very long. So we're going to begin 1.1 today as well, but we are not going to finish it until next class. So these are the learning targets for 1.1. We're going to make and interpret bar graphs for categorical data. Okay, and we're going to identify what makes some graphs of categorical data misleading, so what to watch out for. Okay, we're going to really just interpret today, not make, and then we'll talk about some of those misleading factors. So back to this example that you saw earlier, we talked about this already, that this was a categorical variable and that this was able to be represented in a bar graph. I want to take this and talk about how we can organize it in a chart with 2 more vocab terms. Okay, so this question is on your notes. What's the difference between a data table, a frequency table, and a relative frequency table? The data table shows the raw values. So you could have more than one variable displayed. Okay, that was that big chart that we saw. When we talk about a frequency table, that's a table that takes one variable and its counts. The word frequency means count. And it's basically how often some answer to the variable's question appeared. Relative frequency, this word relative, just means you take the count over the total, and this can be represented in one of 3 ways. A reduced fraction, okay, a decimal, or a percent. A lot of times I'm going to use the decimal or the percent most commonly because this one was intense, which is really nice, but as soon as you change your fraction to like 1 over 450, it's not as obvious what proportion that is when some of these will change. Instead of out of 450, some of them will reduce to like 2 out of 50 or something like that. 3 out of 50. Okay, so we're going to use these most commonly. Fractions are nice of ease of use. You put the number over the total, but in general, our final answer we're going to express as one of those 2. Okay, we already talked about categorical data can be into each of those, just showing you the two different representations. A pie chart for this one, because there were only 4 categories, isn't so bad. These ones are much more challenging to make by hand. A lot of times we will use technology to assist us with pie charts, and we will stick to bar charts when we're doing them by hand. Okay, some things to look out for with these displays. Okay, there is something called a pictograph, which is a bar graph that replaces the bars with pictures. While it's visually appealing, it causes some misleading, skewed information. The height of this bar is representing the frequency, but when you make this computer monitor to scale, this looks significantly larger than this, and not just by a factor of 4. So it skews the proportions. Okay, another thing we want to pay attention to is for this scale. Your y-axis should be labeled, and when it's labeled, it should always start at 0 for one variable statistics, and the scale should be equally distributed, meaning you're counting by the same number each time. So some common ways to make a misleading graph is you can use a pictograph to skew the size. If you have a 3D graph, okay, that's something where the bar graphs have 3 dimension. Okay, a lot of times these are bad as well, because the first bar is going to look bigger just because it's in front, and then it'll skew towards that. So 3D graphs are also something to watch out for. And then things with our scale. We want to make sure that we start at 0. I'm just going to say look for, because these aren't way to make them misleading, but if they don't have these things, they could be misleading. So look for them starting at 0 and having an equal marked scale. So they could leave this off entirely, or it could not be equally spaced. Okay, so going back to the front side, this is where you wouldn't have filled this out, but we're going to go over some of these vocab terms now that we've hit everything and make sure we understand what's going on. So you were asked to survey 10 people about one of these variables. So we're just going to assume that you went around and you found the height of people in the class. So maybe the heights were 58, 60, 67. Got a couple short people here. And then most of the people in the class, let's say, are taller. 67, 68, 70, 70, 71, 68, 69, 72. Okay? Because that's generally more common than the super short, and then same thing with the taller people above 6 foot tall. That's probably a little bit more rare as well. So those are our numbers. I just made those up for you since you were not here. That's our height in inches. And what we're going to do is classify each of these. Make sure we know. The individuals here are the 10 different people. Okay, so I want you to add this, and in class we're adding this in pen. So those are your individuals, the 10 different people. These over here are your variables. Okay, and each one can be classified as continuous and discrete if they're quantitative, and categorical will just be categorical. So going through here, we're going to do that. So this first one, height in inches, that one is a quantitative variable. And because it's quantitative, it can be discrete or continuous. This is a measurement, so it is continuous. Okay, screen time, the amount of time you're on your phone, that is something, again, that is quantitative and continuous, because it's a measurement of how long you were there. Number of pets is quantitative, but it is discrete because you are counting how many pets you have. Amount of sleep lasted out in hours, also quantitative, but continuous. Number of social media platforms, quantitative, but discrete. Again, you are counting how many you have. Birth month number, that's the exception. That one is categorical. Okay, even though it's a number, it is a category representing January, February, March, so on. Age in years, quantitative, continuous. Number of followers, quantitative, discrete, because you're counting. Same thing with that last one. That is quantitative and discrete. Okay, so we've taken care of those. This, when we were talking about height, we could go and make a frequency chart. So we're not going to do it for all of it, but we could classify the different things here. So we had a 58 inches, 60 inches. The next one was 67, 68, and so on. So we would count in 58 there was only one, 60 there was only one, 67 there was only one, 68 there were two of them, and we could continue that process. Then our relative frequency would take each of these numbers and put it over 10 because there are 10 people. And then again, we usually write that as a decimal, so that covers those two things. Displaying the data depends on the type, okay? So a lot of times when we go through here, height, if it's quantitative and continuous, that's going to be a histogram. Okay, we haven't covered, or we're going to cover all of the things for quantitative next time. So the only thing I want you to do is on this one, because categorical is our focus for section 1.1, which we're starting, categorical can be a pie chart or bar chart. And we'll talk more about the other graphs next class. All right, so now what you are going to do to check to make sure you understand what we covered in the lesson is you're going to do these last two problems on your own. Okay, so I want you to pause the video, and when you're done with that, come back and you can check your answers. We'll do this similar thing in class to make sure you feel good about the learning targets for the day. Okay, here. Individuals are the 8 selected U.S. residents, and then we know the variables are in each of those columns there. Each one can be classified as categorical or quantitative, and then for that I also added discrete or continuous just to keep in practice with those types of questions. It wasn't asked here, but I would like you to go ahead and add that on. Okay, so number of family members was discrete, age is continuous, travel time to work is continuous. Remember, for categorical, I may use the word qualitative. You do not have to write that, just so you know when I say it out loud, that's what I'm talking about. Okay, this last one, you just had to count up. Your first column in your chart should have said age in years. We want to get in the practice of labeling our headings. Okay, and there were 14 through 18 there. The frequency was talking about students, or number of students. So there were 5, 4, 9, 17, 50, or excuse me, 5. And then our relative frequency, we divide by the total. So I'm going to add to the bottom here totals. So there were 40 students. You would want to make sure that you didn't miss any by counting those up and making sure there were 40 there. And relative frequency is going to always add to 1. Or if we're talking about percents, it would always add to 100%. So that's something to look out for as well. Okay, your homework for today is on sapling. If you have any trouble getting in or as you go through the problems, please come see me.